Hello gorgeous people on the internet. In this episode we are gonna cover 5 JavaScript concepts that you should know. So things like hoisting, things like scope, async await, callbacks, event queues, call stacks. Oh no, this is gonna be quite crazy, but take a look. I think you're gonna enjoy this one. Maybe you're gonna learn something new, maybe you know a few of these. Let me know what kind of feels weird for you in JavaScript. What do you find the hardest about JavaScript? Let me know in the comments and I'll try to help you out. So without further ado, grab a coffee, grab a Red Bull, whatever floats your boat, and let's get into this episode. Okay, the first one we're gonna talk about is hoisting, which kind of sounds like moist, but it's not. It's something completely different. I need to... All right, good start. Let's get going. So I'm gonna throw up some code here and I'm gonna explain hoisting while we go. So let's start with var. And then we're gonna transition to const eventually. So var, I'm gonna create a name here and set that equal to ed. I'm gonna say console log name, all right? So we know what's happening here. If we console log this out, we're gonna get ed, all right? However, what happens if we move this console log up here to the top? We're gonna get something else. Look, we're gonna get undefined. Now, why is that happening? Well, before our JavaScript actually runs, the compiler takes all the variable declarations and function declarations and moves them all the way to the top. So that's all hoisting is. Takes your variable declarations and function declarations and just moves them to the top. So what's variable declaration? Well, this is one, var name, all right? It can be another one, var items. So we just declare a variable, var items people. All right, so this is how we can declare a variable. This, when you set it equal to something, that's an assignment already. So if I say items equal to 10, all right, so this is a variable assignment. So when we have a variable declaration, the compiler, before it runs our code, takes this and moves it to the top. So what's happening behind the scenes, all right, this is what actually goes on. It's gonna run through your code. The compiler is gonna get here to the var name. It's gonna see this and it's gonna take the var name, it's gonna plop it, move it to the top, and boom, that's it. And here we actually assign it. So this is what happens actually behind the scenes. So here we have it declared, but when we console log, we're getting undefined because it doesn't have a value at this point. If you just declare a variable, the default value is gonna be undefined. So when we console log here, we're gonna get that undefined. And here we are, and when it gets here, we have access to the name, so ed. So if we do down here, then it works. All right, but I kind of wanted to show you what's happening behind the scenes. So we should get undefined and ed now. Okay, well, the same thing kind of happens with function declaration. So if I say function, say name, okay, and I'm just gonna console log hello there here, all right? With this one as well, take a look. If I'm gonna say name, run this, I'm gonna get hello there. However, take a look, I can move this up here. I'm gonna get rid of this and change it back for our name. All right, if I move this up here, say name up here, it's still gonna work. Well, it doesn't work because I messed this one up, but take a look. We get hello there, so we still get hello there. So why is this happening? Well, same thing kind of happens as with variable declaration. So the function behind the scenes is going to be taken and moved all the way to the top. Okay, so say name is still going to work. Okay, there's another way we can define functions though. So if I say var, say age, and set that equal to a function. And I'm actually gonna get rid of these two, all right, just to simplify everything. So we have say name here, all right, this one, and we have say age. However, this is different. And here I'm just gonna say console log, my age is 25, oh no. Okay, now what happens if I call this here? All right, so obviously this is gonna work down here. We know that. Take a look, everything works. However, look, if I move this to the top, it's not gonna work. Boom, error. No, say age is not a function. So why is that happening? Well, if you remember, I told you that there are only two things happening. the compiler takes a look at our function declarations and our variable declarations. So this is a function declaration, so this is going to be plopped and moved to the top. Okay. However, this is a variable declaration that we eventually set equal to a function. So since this is a variable declaration, this is what happens. This gets plopped, moved to the top, and eventually we're going to add say age down here. So look at that. It's not a function. It's just a variable. So when we call it, that's why we get that error saying, hey, say age is not a function. I'm losing my voice. JavaScript is making me depressed. Okay, so down here, again, if I just say age again, it's going to work just fine. But here, since it's just a variable, it's going to throw us that error. So there we go. Run this, boom, 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 everything works. Okay. Now, the difference is if you're probably not going to be worrying about var anymore because we're modern people and we use const and let. Here, it's I believe it's a bit different. So if we declare an add, a name with add, and we console log add, so this works the same way. Hit save. Down here, run this, we get add. However, if we move this to the top, we're actually not going to get undefined. It's going to throw us a nasty error. And the console is going to tell us that, hey, cannot access name before initializing it. Okay, so it actually stops us from doing anything stupid because it probably assumes that you don't want to call something before it's declared and assigned. Okay, so you're probably not going to have that many problems with this. Number 2 is going to be call stack. And for this one, I pulled up these slides because I think it's going to be way easier to visualize than me just explaining it or showing you in code. So all a call stack is just a data structure that kind of dictates the way our functions run, the way our code gets executed. Okay, so let's take a look here. All I have is a function say hello and a say age and a say all that executes both of these up here. And both of these just have a console log, so nothing really interesting. And then we finally invoke this say all, which executes these two. Okay, and then just a console log. So let's take a look on how this code actually gets executed and what's happening here in the call stack. So the first thing that happens is when our code actually runs, so the whole file, so the whole app.js, is that this main thing gets created. And all that is just it just shows us that, hey, our file started running. All right. And the way this works is you can imagine it kind of executes like books, It just kind of stacks like books. So your main function gets executed. Then after you invoke a function, it gets added to the stack like this on top. And once that function finishes, it gets removed from the stack. All right. And then we invoke another function, gets added to the stack, removed, and once our code finishes, even the main gets taken off the stack. But that doesn't really make any sense, so let me kind of show you here on the screen. Okay, so we go through the code, JavaScript checks all of our code, nothing really happens here because they're just function declarations, and then we get to say all, again, nothing happens, just a function declaration, and boom, we have a function invocation. Yeah, boy. All that happens here is once we invoke a function, it gets added to the stack. So now, rather than moving on to console log final, we move into this say all. All right, so we move from here, not down here, we move into the say all. All right, so as you can see, it got added to the stack. So this say all function is running. All right, and the main is running as well. All right, and let's move on. So we are in the say all here, which has a say hello invocation. So we move into the say hello. Boom, that gets added to the stack as well. Then what we do is we have a simple console log up here. So we console log that thing out. And once that finishes, it gets removed from the stack. Cool, once it gets removed from the stack, we can move on. And since we don't have anything else here, any other code, say hello finishes, so that gets removed of the stack, which means we can move on whatever happens in say all, which is say age. All right, we finished the say hello, we went from here to console log, it finished, so we move on. All right, this kind of gives you a visual of what is actually happening behind the scenes. So say age, what's happening? It's going to be added to the stack. Boom, right on top. Pim pam puh. All right, So we have the say age. Now that's continuing and running. Then we just console log that thing out. Once that finishes, gets removed, and say age gets removed as well because we don't have anything else. So good. Now we've successfully finished the say all. We don't have anything else in here. So what happens? It gets removed from the stack. Boom. So we can finally move on to the console log. And all it does, it says console log final. So that gets put out, finishes, and then our code ends. So the main gets removed as well. All right, so I hope this gives you a bit of visual of what's going on behind the scenes and how our code is actually being run. So I think this call stack is actually a very nice way you can visualize on where we are in the code and what's still running and what is finished. So let me go back one more time really quickly to show you. All right, we go through all the code. Say all gets invoked. We move into say all, which invokes say hello. That gets added to the stack. Console log, remove. Then we move on to say age. Console log, remove. And then we finally console log out final. Okay. Number 3 is going to be a short one, but a sweet one. It's going to be IIFEs. Now you might have heard of this one or you saw, and if you don't know what it means, I'll sum it up in 1 minute. So it's an immediately invoked function expression. All right, take a deep breath. I'm going to write it down here for you, and I'm going to explain what's happening. So this is how an IIFE looks. Function, like that. I'm going to console log, hey. All right, and then we invoke it in here. Whoa, that looks weird. And I'm going to console log final here, so like that. All right, let's run this. Boom, boom, boom. We get hey, and we get final. All right, so what is this thing? Well, all it is just a way to write a function and immediately invoke it. That's the name, immediately invoked function expression. So the reason you would write this is so you could have data privacy. And you're gonna see a lot of libraries use this. I think jQuery used this as well. And I'm gonna move on to scopes. So this is gonna be perfectly lined up with scopes. But basically what happens, take a look here. I can just declare any kind of variable I want. I can say var date or var name and set that equal to ed. All right, and out here, if I try to console log name, it's just not gonna work. All right, so this is a way that you can, we get an error. It's gonna say name is not defined. So this is a way where you're gonna run this function and you add all your data or whatever you're building, and this way the function immediately runs, and you also don't have any global variables going on here. Number 4 is gonna be scope. So let's check it out. Scope, we have 2 types of scopes. We have global scope and we have function scope. Perfect. Okay, so how does this work? Well, we can declare a variable name, set this equal to ed. And what you need to know is that basically we have access to this anywhere in our code. So if I console log out your name, that's gonna work just fine. So let me show you. We get ed. And also if I just make a function here, say name, what's gonna happen here if I console log out, hello there, my name is name. All right. So this is gonna work just fine as well. We get ed. Oh wait, we need to actually invoke this function. I apologize. Say name. That didn't run. Okay, now it should run. Let's go. There we go, it works. So what happens here is in the function, the difference is that it actually checks to see if name is available inside here. All right, so function name checks if name is available in here, and it's not. So what it does, it actually looks one level above and it goes into this context, which it finds name. So it's available there. Same thing happens if maybe you have multiple, you can have multiple functions stacked here, maybe say age or something inside this say name. All right, then I can console log out, my age is age. All right, which we don't have. All right, so if I declare an age here, 25, what it does, it basically looks where age is. Is it inside say age? Nope. Then it checks if it's inside say name, which is not. And then finally it checks if it's outside, which it is. So it just adds 25. Okay. Now, let me also invoke this here as well. So say age, run this, and we should get my age 25. Now the interesting thing is, if I declare that that age inside here, const age is 10, we're gonna get 10, as you can see, because it's not gonna go up here anymore. What it does, it checks if say age is available inside here, and it is, so it just uses that. Same thing goes here. If I have this in here, maybe keep it 10, it checks if say age is inside this function. If it's not, it moves up here to the say name. So we're still gonna get 10. All right, but if it's not declared either, then it moves up to 25, so all the way outside. So this way you can have variables that are only functionally scoped, and that's kind of what I showed you here. So if we remove this, we can have function scoped variables. So function, say full name, Heisenberg. Okay, so here I can just have a const name that's Jesse, and I can have a const age that's 30. All right, now this has nothing to do with everything outside here because this is function scoped. So if I just console log out name and age, we're gonna see that if I run this say full name, we're gonna get Jesse and 30. So Jesse 30, as you can see. Okay, so one thing you also need to remember is that all your variables that are functionally scoped, so that are inside of a function, they cannot be used outside. So if you have a function and you have some variables declared in it, you cannot use it. So if I try to console log name out here, it's not gonna work. As you can see, it's gonna throw me an error. However, if I have it outside of a function, if it's not inside of a function, then it works just fine. I can console log it here, I can console log it in here. It doesn't matter because the function itself, it's gonna keep looking until it finds it. All right, so hope that was a bit clear, and that's scopes in general. Number 5 is gonna be a bonus for you because I love you guys so much. I'm gonna cover callbacks, promises, and async await all in one. So this is gonna be fun. Okay, so what is a callback? Let's start with the first one. All a callback is just a function that gets passed in to a parameter of another function, okay? And that callback is gonna run after your first function finishes. So let me kind of show you what it does. So I can just create a function, say name. I can set that equal to, and it can have multiple parameters. Let's say I'm going to pass in a name, and I can pass in a function that's called callback, or any name I want to give, but I'm going to say CB here because it's a bit more clear. All right, so all it happens is that this runs after we finish all of our code in here. So what we can do here is I can say console log running some code. All right, so we can have a lot of different code running in here, and then I can finally, let's say I can even say my name is Ed, my name is name, I'm gonna pass in this, and finally I can call this CB as well. So we need to define this one, the CB. I'm gonna give it a name. I'm gonna say function callback. All right, this is just another function. I'm going to console log this ran at the end. Okay, now what we need to do is we need to invoke the say name. So I can say name. First parameter I'm going to pass in is the name. So I'm going to say Ed. And the second one is going to be this function that we defined down here. So if I pass that in there, that's gonna go in here, and it's gonna run right after we finish everything else. So hit save, run this, and take a look. After our first function finished, we run this callback to execute this one. All right, so that's what a callback is. Now, one thing we need to remember is that this is a synchronous callback, which means that it's going to run line by line. After it finishes, it's going to run this callback, and we are done. Let me show you an asynchronous callback because that's probably what you're going to use a lot of times with set timeout, or you're gonna see when you're doing adding a click listener or things of that sort. So let me quickly show you. Watch this. I'm gonna console log first, then I'm gonna add a console log last, and finally in here in the middle, I'm gonna add a set timeout. So this is again just a function, and take a look, we're just executing another function. So this is a callback function in here. All right, now it's anonymous, so we didn't really give it a name. We could just create a function down here if we want, function hello or something, and we can pass it in here. So I can add hello here, but we can also just add this arrow function, and we can give it a time like 2000, so 2 seconds. I'm gonna say console log from callback. All right, let's run this and see what's happening. So run this, and we're gonna get first, last, and from callback. So that's kind of strange. So why is this happening? Okay, let me show you kind of what's going on in here. I found this cool visualizer where we can see what's happening behind the scenes. So there's a lot of more things here. So we had call stack that we kind of talked about, but we also have things like web APIs, callback queues, and event loops. So all right, mind blowing, but don't worry, we're gonna go through each line. So basically what happens is, you know, we learned about the call stack. Well, theoretically, if we would add, here we have a click listener, right? That would be added to the stack here, all right, that click listener. And by that theory, we wouldn't be able to move on because we would always have that running, right? And then we could have not moved on to console log high. We need to finish that function. It needs to pop off the stack so we can add, we can move on to the console log. So what's happening is that we have these web APIs like set timeout, any listener, click listener, scroll, and things of that sort. And what happens is that they kind of keep track of what's going on behind the scenes, so the code can actually run. So in this example, what we had here is that, all right, so we console log first. Let me remove this. Console log first, this gets added to the stack. It finishes, it moves on to the next one. Set timeout gets added to the stack, and then it moves on to the web APIs, and it keeps track of the 2000 milliseconds. It's gonna disappear out of the stack, and it's gonna move on to the last here. And once that finishes, then it kind of comes back and executes. So it kind of disappears off the stacks and comes back. So in this example that this guy gave here is we just have a click listener here, and every time we click, we run a set timeout of 2000 milliseconds, okay? And then we console log out high, and then we have another set timeout here. Yeah, that's it. All right, so let's run. I'm gonna try to pause this fast. No, pause. All right, so we run this listener. This gets added to the stack here. All right, and remember, since this is one of those asynchronous types, it gets moved on to the web APIs. All right, so let's resume. Take a look, it gets added here, and this pops off the stack. So now we can move on. We can move on to console log high. For some reason, all right, for some reason it disappeared there. And as you can see, now we can move on to console log high, which finishes. So this gets popped off the stack. And then we move on to the next one, set timeout. Now again, this gets moved to the web APIs. So our stack is going to be cleared again, so we can move on to welcome to loop A here. We don't have to wait five seconds. There. All right, set timeout, 5 seconds, gets added to the web. As you can see, it runs. And once it finishes running from here, it gets passed to this callback queue, okay? And it basically, it just makes a queue of everything that's asynchronous. It gets added to this queue. And once your call stack is finished, this is called the event loop. And all it does, it just takes everything from the call, it takes the first item from the callback queue and it pushes it up to the call stack only if it's empty. All right, so if your call stack is empty and you have things stacked in your callback queue, then it gets pushed up and it gets executed. So if we resume this, the timeout is finished. So resume, it's not working. There we go, it gets pushed and the console log happens and we're done. Okay, let's finally take a look at Async Await. And all Async Await does, it makes our code look synchronous without actually being synchronous. It's gonna still be async, but it's gonna be very easy to read and we don't have to add those .thens and chain things together. So it looks very simple. So let me just give you a quick example. We can create a function called get data from database or something, okay? It's just gonna be like that for now. Function get data. All right, so here we would create a promise, new promise, and I'm gonna add an arrow function for now, resolve. I didn't know I didn't do this the first time, but whatever. I'm just gonna add a set timeout because this might take some time to get the data back from the database. I'm gonna say resolve. All right, and I'm gonna say, hey, done. We got our data back, 3000 milliseconds. Good, so that's our promise. So we saw we would have to do like promise.then we could get back the data, and then we would blah, blah, blah. Well, with this one, it looks actually very simple. So what we need to do, the first thing is we need to add async here on the top to let JavaScript know that this is an async function. And the second thing you would use is rather than adding .then, the data that takes time to come back, you would have to add await. So I'm gonna say let result is gonna be equal to, I'm gonna say promise, right? But this wouldn't work, so I will have to add await. So when this finally finishes, it actually adds it to my result. So if I console log out result, after 3 seconds, I should get back that data. So I'm gonna say get data. Run this, let's take a look. We got an error. What does it say? Duplicate parameter name is not allowed. So name? All right, let's take a look. All right, so resolve. I should have named this reject, not resolve. Okay, sorry, hit save. Let's run this. 1, 2, 3. Do we get back? Done. There we go. So take a look. This way, we don't have to add .thens. Everything looks very nice, very simple. We just write it the way we would normally would like to see it. And yeah, that's kind of the basics of it. But we're gonna get more into these when we're actually building out real projects, because that's where I think you can actually see how we use these rather than having these weird abstract kind of examples. So that's it. Thank you again very much for being here with me again. And don't worry if you didn't get all the concepts straight at once. These take some time to learn. So don't stress out, but I kind of wanted to show you all of these to let you know they're there. But yeah, that's it. I'm leaving now, so I can finally go rest because it's been rainy and sunny at the same time, and it's driving me absolutely crazy. So I'll see you next time.